Now we move to causality and ROC, region of convergence. Two resultant transforms from the previous examples are almost identical. However, the ROC for Z transform for signal H1 and H2, in which the values of Z exist, is different. For example, for H1, Z is larger than A, and for H2, Z is less than B. So there are few conditions for causality and ROC. Okay, the first condition is causal. If we have the signal Hn is equal to 1 over 2 with the power of n, which is only exists for n equal and larger than 0, which is right-sided sequence, the ROC is an area outside of pole radius 1 over 2, for example. So this is the right-sided sequence for n larger and equal and larger than 0. So for right-sided sequence, n equal and larger than 0, so the ROC is area outside of pole radius, in this case 1 over 2. So assume alpha is 1 over 2, so the ROC is an area outside of pole radius for right-sided sequence. The second condition is anti-causal. Given Hn equal to 1 over 2 with the power of n that only exists for n less than 0. Let's say it is left for signal n less than 0, we call it as left-sided sequence. Then the ROC is an area inside of pole radius, for example 1 over 2. So assume alpha is 1 over 2. So for left-sided sequence, ROC is an area inside of pole radius z less than half or z less than alpha. For the third condition, what we call non-causal or overlapping ROC. Consider a signal of H3n. There's two conditions, which is right-sided sequence for n equal and larger than 0, which is equal to 1 over 3 with the power of n, and the left-sided sequence n less than 0, which is equal to 2 over 3 with the power of n. So we know that from this Z transform of this signal H3, the ROC for the first condition for the right-sided sequence is the ROC Z1 is larger than 1 over 3, and for the second condition for the left-sided sequence is Z2 less than 2 over 3. So this is Z1, which is larger than 1 over 3, okay, larger than 1 over 3, and Z2 is less than 1 over 3. So we can conclude that the region of conversion for Z transform of signal H3 is Z is larger than 1 over 3 here and less than 2 over 3. So this is the condition 3 for non-causal, or we call overlapping ROC. For condition 4 is non-causal or non-overlapping ROC. We consider a signal H4, which is this is the right-sided sequence for n equal and larger than 0, which is equal to 2 over 3 with the power of n, and the left-sided sequence n less than 0, which is 1 over 3 with the power of n. So for the right-sided sequence, Z1 must be larger than 2 over 3. For left-sided sequence, Z2 must be less than 1 over 3. Okay, for example, Z1 must be larger than 2 over 3. For example, A is 2 over 3. So Z1 must be larger than 2 over 3. The outside region. For Z2, assume that B is equal to 1 over 3. For Z2, must be less than 1 over 3. Okay, so we can see that there's no overlapping ROC between Z1, the outside region, and Z2, the inside shaded region. Therefore, the overall ROC for signal H4 is null or H4 is not exist. The Z transform for H4 is not exist. So you can study for this one. For condition 1 and condition 2, what would be the overall ROC if there is two or more poles of different values? For monograph, you can refer to the following subchapters in monograph. In Chapter 3, Introduction, Definition, Region of Convergence, Direct Application of Z Transform, and the last one is Unilateral Z Transform. With that, thank you.